You know, in programming, the last thing you want to do is waste your time doing the same thing over and over again. So today, we're going to master the fundamental tool that makes your computer do all that repetitive work for you, the loop.
So imagine this. Your program needs to print "Hello World" 5 times. You could just copy and paste the code, right? Sure, but what if it was 1,000 times or 1,000,000? I mean, that's not just tedious. It's a total recipe for disaster if you ever need to change that one line. There has to be a smarter way to handle repetition.
And you know what? There is. This better way is called looping, or sometimes iteration. It's the core idea of telling a computer to repeat an action without you having to spell it out again and again. So today, we're going to master the 3 essential loops that every single programmer has got to know.
All right, first up, let's dive into the absolute workhorse of the loop family, the for loop.
Yeah, you can really think of the for loop as your super reliable counter. It's the tool you grab when you know exactly how many times you need to do something before you even start. You know, like counting from 1 to 10 or going through every item in a shopping list.
So what's so great about the for loop? Well, its real power is how it packs all its logic into one single line. It's got 3 key parts. First, the initialization, that's where you set up your starting point. Then you've got the condition, which is basically the rule that tells the loop when to stop. And finally, the increment, which updates your counter after every single cycle.
Okay, let's check out a classic example to see what this looks like in action. This one little structure tells the computer everything it needs to know. We're telling it, hey, start a counter I at 0, keep going as long as I is less than 10, and, oh yeah, add 1 to I each time you finish. And the result? Hello World gets printed exactly 10 times. It's just so clean, efficient, and perfectly predictable. So the big takeaway here, it's all about clarity. When another programmer, or let's be real, you in 6 months looks at this code, there's absolutely no confusion. That one line tells the entire story. And this kind of predictability is exactly what separates messy code from professional, easy-to-read code.
Okay, that's all great, but what happens when you don't know how many times you need to loop? For that, we're going to need a much more flexible tool, the while loop.
This is where the while loop comes in. It's for those times when you're not sure how many loops you'll need. You know, like waiting for a file to download, or stirring soup until it's hot. You don't know the exact time, you just know the condition that has to be met for you to stop.
Now, here's a really critical detail. A while loop is what we call entry controlled. Think of it like a bouncer at a club. It checks the condition before it even thinks about letting you in. And if that condition isn't true from the very beginning, the code inside that loop, it will never ever run, not even once.
But with all this flexibility comes a pretty big risk, a trap that every programmer needs to know how to avoid.
And that trap is the infinite loop, right? If you forget to put something inside the loop that will eventually make the condition false, well, your loop is just going to run forever and your program will just hang. It's a classic mistake, so you've always got to make sure there's a way out. All right, on to our final loop, the do while. It's a really subtle variation of the while loop, but it has one tiny difference in its behavior that changes everything.
So, unlike the while loop which checks at the door, the do while loop is what we call exit controlled. It runs the code first and then it checks the condition at the very end to see if it should go again. This simple change in order creates a really powerful guarantee.
And that guarantee is this. The code inside a do-while loop will always, without fail, run at least one time. Because that check happens at the end, the first pass is completely automatic.
So, when would you actually use this? Well, this run at least once thing is perfect for certain situations. The classic example is a user menu. I mean, you have to show the options to the user at least once before you can possibly ask them to pick one, right? That's a perfect job for a do-while loop. Okay, so we've got 3 powerful tools in our belt now: for, while, and do while. The big question is, how do you pick the right one for the job?
This table right here is a fantastic way to see it all at a glance. But really, the key difference boils down to one simple thing. When does the condition get checked? For and while are cautious. They check at the beginning. Do while just dives in and checks at the end.
But hey, let's make it even simpler. You can basically just ask yourself these 3 simple questions. First, do I know the exact count? If the answer is yes, just use a for loop. If it's no, then ask yourself, could this loop potentially run 0 times? If yes, while is your safe bet. But if that code absolutely must run at least once,
then do while is exactly what you need.
So, when you boil it all down, mastering loops isn't really about memorizing code. It's about understanding the kind of repetition you need for your task. The for loop is your go-to for definite, counted tasks. The while loop is for all those indefinite situations. And do while is for those special cases that have to run at least once to get the ball rolling.
Honestly, choosing the right loop is something that's going to become second nature with a little practice. You now have the fundamental building blocks to automate pretty much anything and really control how your programs run. You're not just giving single commands anymore. You're creating complex automated systems. So the only question left is, what are you going to build first?